In this lab, we'll be learning about the different types of mixtures that we may encounter in chemistry. For the lab report, you'll define each solution as one of the types of mixtures that we can encounter. Those are a solution, a colloid, a suspension, or an emulsion. And you'll see at least one example of each of those in this lab. The main method you'll use to differentiate between a solution and the other types of mixtures is the Tyndall effect. This is a light scattering effect that certain mixtures have and is very similar to Rayleigh scattering, which is why the sky is blue. Your definitions should be in the theory section of your lab report. Do some research on each type of mixture and the Tyndall effect, and then in your lab report identify whether each mixture has the Tyndall effect, whether it separates on standing or not, and then classify it as a solution, colloid, suspension, or emulsion. This should be in the data section of the lab, and it should be in a data table. Finally, answer the following questions for the discussion section of the lab report. What observable physical characteristic allows you to discriminate a colloid from a suspension? 2. What observable physical characteristic allows you to discriminate a solution from a colloid? 3. Does the characteristics of the oil change when soap is added? 4. Some samples are difficult to classify because their physical properties are intermediate or mixed between the characteristics of solutions, colloids, and suspensions. Why do you think some samples display such intermediate/mixed properties? 5. Consider a mixture of a solid material and water that clearly exhibits the properties of a suspension. If you created a similar mixture but used a different solvent, such as acetone or vegetable oil, is it possible that the mixture could behave as a colloid instead? Why do you think that? And 6. Is it possible for a solid material to form a solution in one solvent but a colloid in another? Why do you think that could be possible? The materials you'll need for this lab include club soda, and club soda is just carbon dioxide dissolved in water. You'll need table salt. You'll need starch, milk, oil, talcum powder or some kind of equivalent. You'll need incense, a laser pointer, and then you'll need 7 medium test tubes, 6 corks, a test tube rack, a glass stir rod, and about 300 milliliters of distilled water. For our procedure, first, label each test tube with what will be put in it. Label the club soda test tube with CO2 because we're really just concerned about the carbon dioxide. Our second step is fill 5 of the test tubes up about halfway with the water. The test tube that will have the club soda should be empty, and the test tube for the incense should be empty. Step 3. Pour talcum powder, starch, and salt in their respective labeled test tubes. Then, fill up the test tube labeled CO2 with the club soda. Next, put oil and milk in their respective test tubes. And then, finally, light the incense, get it smoking a little bit, and then put it into the test tube. I want you to put corks in all of the test tubes except for the club soda. The CO2 is already fully dissolved, and putting a cork in it is just a good way to accidentally shake it and make a mess. Now, invert each test tube to mix the contents. Test each test tube with a laser pointer to measure for the Tyndall effect. Be careful with this because it's very easy to damage someone's eyes with a laser pointer. They have a very powerful beam. Now, you'll probably notice that the oil pretty obviously does not want to mix with the water. Once you've tested for the Tyndall effect, put some dish soap into the oil-water mixture. Cap it and shake it vigorously and test for the Tyndall effect again. Once you've completed, all of these mixtures can be washed down the drain. Wash all the test tubes out and return everything to where you found it.